This is the fifth video in the series to do with level 3 probability distributions. We're looking at binomial distributions at the moment, and we've got four characteristics to do with binomial distributions. First, there's a fixed number of trials. The next one, every trial is independent, so that means the result of one trial does not have any impact on the second trial, the third trial, etc. Binomial, as the name suggests, there are two possible outcomes. There's yes or no, success or fail. And the probability of success remains constant throughout all of the trials. We have a formula sheet. Here's a piece of it that will be given in the exam. And it's got the formula here for finding the probability of successes of a set number of trials, probability of binomial distribution. And we've got the mean number, which comes up occasionally, is equal to the n number of trials times pi, which is the probability. So we've got this symbol means the mean, average. N is equal to the number of fixed trials. And then we have pi, which is Greek for p, which is equal to probability. And that's the probability for each individual trial. As we can see, standard deviation, we've got a formula here, which these numbers will make more sense as we go through the tutorial. And we know that variance is standard deviation squared. So if we just get rid of the square root symbol, then that gives us the variance. Okay, so I want to try and explain this formula to you a little bit. And where does this all come from? So I'm going to use a probability tree to show you how it comes about. So let's say we know from historical information that the probability that a staff member chooses coffee when they go to the staff room is 0.65. Now there's our fixed probability. It remains constant throughout. Sometimes we have to make assumptions that this does remain constant throughout because it could depend on all sorts of things, time of day, etc. We want to know the probability that out of the next 4 people that come to the staff room, only one of them chooses coffee. So if we draw a probability tree, now we know a coffee drinker is 0.65, not a coffee drinker, it's going to be 0.35. Now if we've got first, second, third, fourth trial, we can see that out of 4 people, exactly 1 gets coffee. So the first gets coffee and the other 3 do not. So following the yellow highlight. Or it could be going down not, yes, no, 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 yes, no, 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 yes. So we can see 1, 2, 3, 4 combinations. Now every single branch on this tree is exactly the same. 0.65 times by 0.35 to the power of 3. So that's the probability of success to the power of 1 times by the probability of a fail to the power of 3. And it's exactly the same. So we've got 4 lots of this answer. So let's have a look at how the formula comes about. So the formula here says this little piece here. Now that's combinations, which we've just seen as 4. So we've got nx. Now sometimes the formula, and it's more likely to see it written like this, combinations with n number of trials and x successes. Or on the calculator, I think it has a little r there. So what we've got is that's the piece that says 4 times. So we've got 4 times, well, each of these has 0.65, and then it's times by 0.35 to the power of 3. So if we look back at the formula, it has ncx times by p is the probability, that's that, to the power of x. We wanted 1 success, so that's to the power of 1. Times by, it's got this funny little piece, 1 minus pi. 1 minus pi is 1, subtract the probability of success. That's the probability of fail. That's that there. And then it's got the number of trials minus the number of successes you want. That gives you the number of fails. That was the point. That was the 3 fails that we want. So that's how your formula comes about. So if we were to draw a picture of this, we could have 0 people drinking coffee, choosing coffee, 4, 1, 2, and 3. And this shows us it's binomial. We wanted to find exactly 1, so we did exactly 1. Now, what if we wanted to know the probability that x was less than 3? So less than 3, we wanted 0, 1 and 2. Well, we quite simply do this formula 3 times. Once when x is 0, we already did it when x is 1, and once when x is 2. So we've already got that from that first time around. X is 1, probability that x equals 0, we would have the combinations would still be 4 multiplied by probability of success. We want 0 successes multiplied by this probability of fail, and we want 4 fails. That would be that formula. Then for 2, combinations would still be 4 combinations. Sorry, no, it wouldn't. We want 0 successes, not. That would be 1 combination. The 2 successes would be, looking at our tree, success, not, success, not. And we can see the pattern. And our combinations button on our calculator will tell us that. Okay, so we were going to do the 2 here now. So we've now got multiplied by the probability of success to the power of 2, multiplied by the probability of fail. We've got 2 successes, we want 2 fails. Okay, so you get the idea. The combinations button on your calculator, we've got 2 choices. If we have a calculator like this, Casio FX82, the combinations button's right there. So the one that we did do, then we saw for 4 trials, 1 success. So if we went 4 trials, we have to use the shift button. 1 success, you can see there that combinations are 4. Okay, if we have, looking at this calculator here, if we just clear it, we have, we just go back to our first menu that we would be on. So if we were just coming into this calculator, exit out of all these settings. So we're just on a math function here. We go here to options. We're looking for probability, and it's not there, so we have to use the F6 button. There's our probability under F3, and these are combinations. So 4 trials, combinations, 1 success equals, and there's our combinations of 4. Okay, if you want to see how to do this much more quickly on a scientific calculator, watch the special video on using your scientific calculator.